Alright, so we're on chapter 1. And we did 1.1 already. Linear equations. Oh, sorry, in this book, I guess. Sorry, in this book, chapter 2, I'm sorry. Sorry about that. Yeah, we did 2.1 last time in this book. It's 1.1 in the other book. Okay, now we're going to talk about lines today. And equations of lines. So we're going to start off with slope. Hopefully it's not a new concept, but how a line rises or falls from left to right is called the slope. And there's a formula. If I give you 2 points to calculate the slope of the line that goes through those 2 points, we have a formula. Last time we talked about plotting points, and we talked about the distance formula. Now, we're going to talk about a line, and the very first thing we learn about a line is the slope of a line. And so, it's a ratio. It's a fraction that tells how much the y's change divided by how much the x's change. And so that's an indication of how steep the line is. And if I give you 2 points, the formula, based off of the same kind of setup that we had for the distance between 2 points, call one point x1, y1, the other point x2, y2, and you subtract the x's in the denominator, subtract the y's in the numerator, and that's your slope. The variable for slope is m, and the order in which you subtract is important. Whatever order you choose for the numerator needs to be the same order for the denominator. And so, as an example, let's take the points -3, 4, and 5, -2. And I'm going to find the slope of the line that connects these 2 points. There's only one line that connects these 2 points. Find the slope of that line. We're just going to plug into the formula, that's all. So now this is another formula on top of the formulas we had last time, the distance formula, the midpoint formula. Now we have the slope between 2 points, the formula. Okay? So these are the y's, and these are the x's. And so I would call this guy like x1, this guy would be like our x2. This guy would be like our y1, and that makes this guy our y2. If I'm following the formula, then I'll get a -2 take away 4. Denominator, 5 take away a -3. You don't have to use parentheses, but it helps. So I use my second point, I subtract my first point, but I have to use my y's in the numerator, x's in the denominator. What is a -2 take away 4?
-6.
It's a -6. You owe somebody $2 and you owe them $4 more, you owe them 6 altogether. A double negative is like adding. So the denominator is 8. And that reduces. You always want them, if you have a fraction, you want it in smallest term, lowest terms. So this, when you take the 2 out of both, the answer is going to be a -3/4. Okay, so you'll be doing that. Questions about that? It could get tricky because when we have a fraction, sometimes we need to worry about division by 0. What this book says right here, though, is just make sure that doesn't happen. You'll never have 0 as long as your x1 and x2 are different. When they're the same, your x1 and x2, then you have a problem because you'll be dividing by 0. And we'll get to what that means as far as a line. But these lines are called non-vertical, meaning that they're not a vertical line. Vertical is up and down. Any line that's not vertical, we can use this formula for. But when we have a vertical line, we're going to see that the slope needs to be something else. Question? Okay, good. So they go through some examples. Okay, next up then, that thing was too small. Let me blow it up now. Well, that's too big now. Oh well. Can't find a happy medium. Okay, so with slope, there's different values for the slope that we could have. If the slope is positive, then that's one kind of line. If the slope is negative, that's another kind of line. When the slope is 0, that's a third kind of line. And then the last part right here is number 4. What happens when you have a vertical line? So a line that rises from left to right, an example would be like the one we had on our first slide. That's a positive sloping line. A line that falls from left to right, that's a negative sloping line. So with our first one, m is positive, greater than 0. With our second one, m is negative, less than 0. The third one is a horizontal line. The red is the x and y axis. I just didn't label them. But a horizontal line is one that lies parallel to the x axis. That's a horizontal line. For that, there is no slope. M equals 0. If you try to do the change in y divided by the change in x for any 2 points on that line, there is no change in y. All the points on that line have exactly the same y value. So the numerator to slope is 0. That's a horizontal line. And then finally here, a line with an undefined slope is vertical. So that's a line that's parallel to the y-axis. This is called vertical. And this guy here is called horizontal. Okay. So in our example, the 2 points that I chose, we had a negative slope. It was negative 3/4. When we go to graph the line, it should fall from left to right if we were to graph the line that connects those 2 points. I don't know why we can't do that. Let's go back. 1, 2, 3, negative 3. 1, 2, 3, 4. Negative 3, 4 is here. And the other point was 5, negative 2. 1, 2, 3, 4, 5. Go down 2. We'll put it right there. Yeah, when we connect those, we get a line that falls from left to right. Negative slope. Okay, good. Questions about that? Alright, sounds good. Sorry. Oh, come on. Okay, next up is I know we have a